We need to determine the equation of a parabola with focus at 0, -3 and vertex at -1, -3. Let us begin. So here, we'll start by considering a straight line. So on this line, we're going to consider 2 points. Let's say one of the point is denoted by V with the coordinates -1, -3. So this is going to be the coordinates of the vertex of the parabola. And on the same line, we have another point with coordinates 0, -3. Now, by definition, any line on which the vertex and the focus of the parabola lie is going to be referred to as the axis of symmetry line. Now, what we'll do, we're going to consider a point. Another point A, let's say its coordinates are A, B. And through this point, we're going to pass another straight line such that it is perpendicular to the axis of symmetry line, and this line is referred to as the directrix line. Now, our goal will be to determine the equation of the directrix lines, and once we have the equation, we'll be easily able to obtain the equation of the parabola. Now, the way we choose the directrix line is very important. That means the position of A is very important on the axis of symmetry line. Its position should be chosen in such a way such that its distance from the vertex, that means distance of point A from the vertex, is exactly equals to the distance of the focus from the vertex. So that means these two distances must be exactly of the same length. Only then we can say that the vertical line, which is will be the directrix for the parabola. Now, how do we find out the equation of the directrix? Now, in order to find out the equation of the directrix, there are two information that we need. One is the point through which the directrix line passes and the slope of the line, because we will be using here the point slope form of a line to obtain the equation of a directrix. So here the point slope form states that if we have, let's say, a point with coordinates, let's say A, B, and then we have a straight line passing through that particular point having a slope of m, then the equation of the line is given by y minus b equals to the slope m multiplied to x minus a. So let's try to find out the coordinates of point A, B, and once we have that point, we can also find out the slope. Now here, the vertex is going to be the midpoint of the line segment joining point A and the focus of the parabola. Now that means we can add the x coordinate of point A and point F, so A will get added to 0, divided by 2, and for the y coordinate, we sum of the y coordinates of point A and point F divided by 2, and this will be equivalent to the coordinates of the vertex, so that's -1, -3. Now, we can equate them to get A plus 0 over 2 equals to -1, and B minus 3 over 2 equals to -3. So we're equating the x coordinates and the y coordinate. So that's going to give us A equals to -2. B will be equals to -3. So that means coordinates of point A, that's going to be -2, -3. Now that we have the coordinates of point A, let's try to figure out the slope of the directrix line. For this, we will first try to find out the slope of the axis of symmetry line. So let the slope of the axis of symmetry line be denoted by m1. We can easily obtain the slope of the axis of symmetry line because the line passes through 2 points, V and F, and both of the coordinate values are given to us. So we'll have to take a ratio. We'll start by taking the difference of the y coordinate in the numerator. So let's say we take -3, which is the y coordinate of the vertex, and from it subtract the y coordinate of the focus, so that's -3, divided by, we'll take the difference of the x coordinate, so we'll take -1, and from it subtract 0. Now, this is going to be equals to 0, and that means the slope of the axis of symmetry line is 0. If the slope of the axis of symmetry line is 0, then what will be the slope of the directrix line which is perpendicular to each other? So that means S is going to be undefined. So we can say that slope of directrix is going to be undefined. The reason why it is undefined, because if our slope m1, which is the axis of the symmetry line, is 0, it means that this is parallel to the x-axis. If it is parallel to the x-axis, automatically the directrix line is going to be parallel to the y-axis, and any line parallel to the y-axis has an undefined slope. If it is having an undefined slope, then we can immediately define the equation of that particular line. So the equation of that particular line is going to be defined by x equals to a. So a is the x coordinate of point A, and we have already obtained a value of A. So A is -2, which means that the equation of the directrix lines is going to be x equals to -2. So now we have the equation of the directrix lines. So in this case, we actually don't need the point slope form. So now we have the equation of the directrix. We also have the coordinates of the focus. We are ready to find out the equation of the parabola. So let's begin by first considering a point P on the plane having the coordinates h, k, and the point P is chosen in a very specific way, such that if we join point P and point F and we drop a perpendicular from point P on the directrix line such that it meets the line at M, then by definition we can say that PF will be equals to PM. This is what we're going to define the equation of a parabola. Here P is the locus of the parabola. Let's try to find out the length of PF. We can easily find out the length because the coordinates of the endpoints are given to us. So here we can use the distance formula. So we'll take a square root. Underneath the square root we take the difference of the x coordinate. So that's h minus 0, square it and then add it to the difference of the y coordinate. So we'll take k minus -3, which gives us k plus 3 whole square, equals to, now how do we obtain the value of PM? PM is the perpendicular distance of this point P from the straight line x equals to -2. So there's a specific formula to find out the perpendicular distance. Let's go through that formula quickly. So let's say we have a point P with the coordinates x1, y1, and we have a straight line with the equation ax plus by plus c equals to 0. This is the equation of the line given in the general form. Then PM is going to be the perpendicular distance of the point P from the straight line, and this distance can be obtained by taking the absolute value. Underneath inside the absolute value we'll take A, which is the coefficient of x, and multiply with the x coordinate of point P. Add it to B, which is the coefficient of y, and multiply it to the y coordinate of point P plus the constant term of the line divided by the square root of the sum of the squares of coefficient of x and y. So we'll use the same formula. So here we have the point P with coordinates h, k. That's the x coordinate as h and the y coordinate as k. The equation of the line is given by x equals to -2. Let's try to rewrite it in the general form. So we have 1 multiplied to x. There is no y term here, so we can rewrite it as 0 times y. And we're going to transpose -2 to the left hand side to get +2. So this will be equals to 0, such that the coefficient of x is 1 and coefficient of y is 0. Now we'll take the ratio, and now I'll start with the numerator. So we have 1 multiplied to h added to 0 times k added to 2 and divided by the square root of 1 squared plus 0 squared. So that's going to give us the square root of, so let's expand. So we have h squared, k plus 3 whole squared will become k squared plus 6k plus 9 equals to, so here we have absolute value of h plus 2. Squaring both sides gives us h squared plus k squared plus 6k plus 9, and then we have to square this value h plus 2 whole squared to get h squared plus 4h plus 4. So h squared and h squared will get cancelled out. So here we have k squared. So we'll transpose 4h to the left hand side to get -4h plus 6k added to, so we have 9 minus 4, that will be +5 equals to 0. We're almost there. Finally, we'll have to replace the value of h with x and the value of k with y to obtain the equation of the parabola. So we get y squared minus 4x plus 6y plus 5 equals to 0, and this is going to be the required equation of the parabola.